Hello dear friends! I hope that not too much time has passed between you started watching this video and finished watching the previous one. And if a lot of time has passed since then, I will remind you about the last issues that we went through together. In the previous video, we learned how to move a hero using given coordinates at a certain speed. We have used vector-free move towards method and called the method inside the update function. In this video, we'll learn how to move a hero towards the target hex correctly. Let's get started. I will create a new script and name it move. I will attach the script to the hero prefab. This script will manage the movement of a hero. So far, the script does nothing, it is just a component of the hero object. And that's enough for now. Before we continue, I will open the hero script and delete the statements that are no longer needed. It's important. Good. Now open the move script. I have already created methods and variables that will help us. But before I explain each statement, let's discuss how it's gonna work. When I select the target hex, I highlight the optimal path. We don't do anything else with highlighted hexes. A player determines the target hex by the first click on a hex, but the second click on the same hex should cause a hero to move. If a player clicked a second time on another hex, then a new target hex should be determined. In this case, a hero shouldn't start moving. So the first thing we need to add is the ability to respond to the first click and second click differently. The second thing to do is to collect all the optimal path hexes into one list. Having the opportunity to work with a list or array, we can effectively use loops. To do this, all highlighted hexes will be included in one list, and we are going to use this list for all of the following tasks. A hero has to follow the optimal path correctly. So we need to explain to a hero which hex is first, which hex is second, and which one is the last one. A hero cannot start moving from the end or from the middle of the optimal path. Therefore, we need to sort the hexes correctly. The next step is to move a hero to the first hex of the optimal path. When a hero starts moving, we should activate the movement animation. The fairy must start flying. When a hero reaches the first hex of the optimal path, then a hero starts moving to the second hex of the optimal path. Then a hero moves along the optimal path and must stop moving when it reaches the target hex. At this point, we must stop the movement animation. Well, this is an interesting task. Let's go for it. Let's start by adjusting the response to click. Open the Click on Me class. Let's see what's happening when we click on a hex. We check if the hex is the neighboring one or not. If the hex is a neighboring hex, then we call the makeMeTargetToMove method. We define the hex as the target and highlight the optimal path. To highlight the optimal path, we use matchPath method. Let me extract a new method, select all statements inside, and extract new methods. Name it selectTargetToMove. We didn't change anything, but freed up some space for another check. Let's return to the moment when we click on a hex. When a player clicks on a hex for the first time, a player selects the target hex and determines the optimal path. When a player clicks a second time, a hero starts moving. So a hex can be either target or non-target. We have an isTargetHex boolean. Let me rename it just to make it easier to distinguish a variable from other variables. We're going to have other targets, so renaming will help. I will name it isTargetToMove. When a player clicks on hex for the first time, the value of isTargetToMove variable is false, and it should become true. If a player clicks on a hex a second time, the value of isTargetToMove variable is already equal to true. If it is true, then a hero starts moving. Therefore, I will add an if statement and check if the value of the isTargetToMove variable is not true. If it is not true, then we set a target hex and highlight the optimal path. We call selectTargetToMove method. So if it is true, then we do something else. Okay, what exactly we want to do if the clicked hex is a target hex? Well, we want a hero to start moving. And we need to call a method that will move a hero towards the target hex. First, check if everything works correctly. Print a message here and go to Unity. click on hex twice and it is okay. We see the message. Now we are ready to create a method that will move a hero. So I will refer to the current attacker, and using getComponent method, I will call the startMoving method. The move script is a component of a hero object. We haven't created the startMoving method yet. Go to the move script. I will activate the startMoving method. I will not activate other statements for a while. First, we need to collect all highlighted hexes of the optimal path in one list. Let me open the optimal path class. Here, every time we call the matchPath method, we fill the optimal path list with new objects of BattleHex type. Next time I call the method, I will add more hexes without clearing the list. This is not what we need. We need to get a new list every time we call the matchPath method. So I will clear the list using the clear method. It's better to put all the clearing tasks into one method, and we will do so when we use delegates. We have collected the list of BattleHex type, but I want a hero to take a position in the middle of the hex sprite, and not in the middle of the BattleHex object. The coordinates of the BattleHex object do not always coincide with the coordinates of the sprite. The image of the BattleHex object is stored inside its child object. It is a landscape object. So I need a method to convert the list with hexes into the list with their images. There is one more point that we need to consider. The first element of the optimal path list is the target hex. The second element is the hex adjacent to the target hex, and so on. Obviously, we need to start the movement from the hex closest to the starting hex, not from the last position, which is the target hex. We may solve all these issues in different ways, but I will try to choose the simplest solutions. I have declared a variable of move type to access the move component. Remember that the move and the optimal path scripts are components of the same object. So I use the getComponent method inside the start function to refer to the move class. I will create a method that will help to sort the elements of the list. Name it manage_path and let me call the method inside the matchPath method. Now I will explain its statements. I have declared a list of image type to store all landscape images of hexes included in the optimal path. Don't forget to add Unity Engine UI namespace to be able to apply objects of image type. Since we are going to fill the list every time we call the matchPath method, I will clear the landscapes list at the beginning of the method's execution. The next statement reorder the elements in an optimal path list. This time I am going to use reverse method. The reverse method is a member of a list class. It reverses the order of the elements in the entire list. It doesn't return any value, so I will write the list name that should be reversed and call the method. It was easy. Using the for each loop, I will fill the landscapes list with images of landscape object. The last statement sends information about the optimal path to the move class. We haven't declared the path list yet. We're ready to move on to the most important part of this video. Open the move script and let's activate statements I have written here. Let's discuss them one by one. IsMoving variable helps us to start and stop the movement. If it is true, then we will run the statements written inside the update function. When it is false, the update function will not run the isMoving method and a hero will stop moving. A hero variable stores the reference to the hero component. I will refer to the hero component inside the start function. We have talked about the path list of image type. It stores all images of hexes that are included in optimal path. Do not forget to add Unity Engine UI namespace to be able to apply objects of image type. Total steps variable of integer type counts the number of elements stored inside the path list. The current step variable will be used as an index to switch from one element of the path list to another, to know which step we are taking at a particular moment. Target position of vector-free type stores coordinates of a target position. Speed of animation variable helps us control the speed of the movement animation. I have assigned 2 to the variable. I hope it is enough to make everything look natural. Okay, that's it. Let's apply all those variables. Inside the update function, we run HeroIsMoving method. We run it once per frame if isMoving variable is true. If I call the method in the update function directly, then we will have an error. The method will be executed every frame. The update function will start before we select the optimal path. We fill the data regarding the optimal path when we click on a hex. Since that, when we start the game, we will get null reference exception error. That's why I use boolean inside the update function and call the HeroIsMoving method only when the boolean becomes true. StartsMoving method sets values to the current step and total steps variable. The first element of a list has 0 index, so the initial value of the current step variable is equal to 0. To get the value of total steps variable, I will use the counts method and subtract 1. We're going to compare the total steps variable with the current step variable, which is used as an index of the list. That's why I subtract 1 here. For example, if a hero's velocity is 4, then we will have 4 elements inside the path list. So total steps variable is equal to 3, since we count elements starting from 0. Let's talk about animation a bit later. StartsMoving sets a true value to the isMoving boolean, activating the code written in the update function. ResetTargetPosition method sets the coordinates of the hex to take a new step. Remember that we take the first step to the hex closest to the starting hex. Therefore, the coordinates of the first target position will be determined by the coordinates of the first element. Then we set new coordinates for the next step and take the second step. To get new coordinates, we use the value of the current step variable. It shows which element of the path list is defined as the target position. Changing the value of the current step variable, we move from one hex to the next one. We're going to change x and y coordinates of the current position, and we don't need to change z coordinates. If I change the z coordinate of a hero object, it may disappear from the camera visible area. Given all this, I will write the following coordinates. Transform position x refers to the x coordinates of the target position, and transform position y refers to the y coordinate of the target position. Since we are not going to change z coordinate, I will write transform position z that refers to the z coordinate of a hero object. Okay, we need a method that sets a new value to the current step variable. We will use another method that is a member of vector-free structure. Its syntax looks like this. The method returns the distance between A and B positions. A and B variables are of type vector-free. The idea is very simple. When the distance between the current position and a target position is very short, then we change the target position and define a new one. We have declared two variables, total steps and current step. Now I need a way to adjust the current step variable's value. I will write the if statement and I will add two conditions. The first condition will check if the distance between the transform position and the target position is less than very small float number. If the distance is close to 0, then it means that a hero almost reached the target position, and we can set a new target position. A second condition of the if statement will check if a hero has taken all steps that were planned. We must stop moving after a hero reaches the last hex of the optimal path, so the current step variable must be less than total steps variable. If these two conditions are true, then we adjust the current steps variable's value. ManageSteps method will be called inside the HeroIsMoving method. Well, now we can activate movement animation. Before we do that, let's think about what will happen when our hero reaches the target hex. We need to stop moving a hero, and we will need to stop movement animation. So I will create a new method and call it StopsMoving. Now, when do we call this method? We call the method when the distance between the current position and the target position is close to 0, and the value of current steps variable is not less than the value of total steps variable anymore. So I will add else if statement and add only one condition. I will call StopsMoving method here inside the code block of the else if statement. Good. Let's activate the movement animation. We want to activate the animation when a hero's movement begins. We have a start moving method where I will activate one more statement. We remember that animator component is attached to the hero object. I will select a hero object and open the animator window. Here I can see the transition between idle animation and movement animation. The transition is activated by the value of the isMoving variable. If we set its value to true, then the movement animation will be activated. So I need to select setBool method here and write parameters of the method. setBool method belongs to the animator class and sets the value of the given boolean parameter. You can identify the parameter by name, but the name must be the same as the parameter name you want to change in the animator. I want to change isMoving variable, so the first parameter is going to be isMoving. Since it is of string type, I should use quotes. And the next parameter is the value of the bool variable I want to set. It is a true value. And I need to stop movement animation when a hero reaches the target hex. This time I will use the stops_moving method to deactivate the animation. Deactivating an animation is as simple as activating it. This time, instead of true, I will write the false as the second parameter. To set a false value to the isMoving variable, I will set the opposite value to it. This statement means that if the value of the variable was true, then it becomes false, and if it was false, then it becomes true. Hero isMoving method uses moveTowards method. It is called once per frame. Transform position is current position of a hero. Target position is a position of a hex defined as a current target for movement. And don't forget to apply time delta time. Finally, go to Unity and see how it goes. Press the play button and click on a hex twice. Good, you have done a great job. Movement is the foundation of the game. Let's resume this video. First, we provided a different response to the first click and to the second click. Then, we collected all the hexes of the optimal path in one list. We changed the order of the elements in the list so that the move script with its members was able to use the list to move a hero. Then, a hero started moving towards the first hex of the field list. We used update function and moveTowards method to make hero move towards its first object. And when a hero reaches a first hex, we change the coordinates of the target hex so that a hero starts moving towards the second hex of the optimal path. We activated animation when the hero's movement began. We continued to change the coordinates of the hexes till a hero reaches the final target hex. And finally, we stopped the movement and animation of the movement. Very good. See you in the upcoming video.